Alright, this is lesson A2. We're doing volumes of revolution again, the shell method, but this time, instead of revolving around just the x and y axis, let's do some other lines. So for revolutions about other lines involving the x and y axis, the formula is still the same, right? The 2 pi, the integral from a to b, rh dx dy. But instead of r being always x or y, or perhaps negative x or negative y, the r is really a little bit harder to find. Okay. Remember when we do this that r is a radius, h is a height, so these must be non-negative values. All right. And to do this, I'm going to actually show you how to do this with example number 1, and how it varies with the different axes, and how it connects to what you learned in part 1. Okay. So I want you to use the shell method this time just to set up the integrals, which can be used to find volumes of solids formed when the region bounded by the curve y equals root x minus 1. Lovely, root x minus 1. Yes, the square root function. The line y equals 0. Oh yes, the x-axis. And the line x equals to 5, so that's right here, is revolved around the following. Okay, now if I revolve it around the y-axis, that's part A. Yeah, the y-axis. Okay. I'm going to take a representative element here, which is going to be parallel. That's why it's parashell. And then remember, it's 2 pi rh. So in this case, the r value, and I'm going to call this r right here, and denote this as r sub a for part A. And of course, I hope you can see that r sub a, I'm going to do that out here, r sub a is just the x value, right? The distance from the axis of rotation, which is the y-axis, to that representative element is really just the x value. And then the height, the height would be, yes, that's the height. So the height is just the function root x minus 1. Okay, so let's go. The y-axis, volume, 2 pi, the integral from, and yes, this is dx. So we're integrating from 1 to 5. Yes, starting at 1, ending at 5. Not starting at 0, remember, starting at 1. The radius, which is x. The height, root x minus 1 dx. Done. Okay. Now, let's see what happens when I change the radius. Or not the radius, the axis of rotation, which of course does change the radius. Now, if the axis of rotation is here, where x equals to negative 2, notice the radius from that same representative element is now this distance. I'll call it r sub b. Now, r sub b seems to be the previous value of x, but I have this little extra bit over here, and this distance is an extra 2 units. So r sub b is x, but an extra 2 units, so x plus 2. And therefore my volume equation changes by making the radius now not x, but that's right, x plus 2. And thankfully we don't have to evaluate this integral. Okay. Can you try part C, please? X now equals to 5. Oh, that uses this as the axis of rotation. So the representative element, the radius, must be this distance, r sub c. Can you figure out what r sub c is in this case? Yeah, that whole thing in yellow is x, right? But if I were now to highlight this in purple, the distance from here to there, that is a full 5 units. R sub c looks like that horizontal pink highlighted line minus the horizontal yellow highlighted line. So therefore, if you wrote down r sub c being 5 minus x, I'm so glad you did that, because you are correct. So the volume in this case, 2 pi, 1 to 5, 5 minus x times root x minus 1 dx. Whew. Okay. So notice that part A was really just a review from what we did in lesson A1. This is review of A1, where we had the axis of rotation on the y-axis. Now, by shifting the axis of rotation or revolution off the y-axis, notice what happens is that the radius has to change. Okay, example number 2. Find the volume solid formed by revolving the region bounded by x equals to y squared. Oh, what's that? Oh, yeah, that's that sideways parabola. X equals to y squared. So x equals to y squared. The line x equals to 4. Here we go, x equals to 4. And about the line, y equals -3. Now, if this is x is 4, then the y value here must be 2, right? So 2, here's 1, -1, -2. So, in this case, the axis of rotation line is way down here at -3. Okay, let's think about this. Pair of shells. So our representative elements must be parallel. Here's my slice of bread to the axis of rotation, which means that my radius would be this entire distance, the radius, and the height would be this distance here, the height. Okay. I'm thinking this is going to be something in terms of dy. So let's think about this. What is the actual radius then? Well, I hope you realize that the distance from the x-axis to that representative element, that one I've just highlighted here in yellow, that's just the variable y. Okay. And then the part that's from the axis, the x-axis, all the way down to the axis of revolution, that is the same throughout. That's just the value of 3, right? So hopefully you can see that r should be just then 3 plus y. If you're looking at h, this expression x equals to y squared actually represents this part, because that's x. That's not h though. This entire distance from here to there is not h either, but that's 4. So I hope you can see then, therefore, h just equals to 4 minus this x value here, which is just, we can write down x, but I want things in terms of y, and of course x equals to y squared. So h is equal to 4 minus y squared. If you got that, that's great. The only thing we're left with is, where are we integrating from? And in this case, the lowest y value is -2. The highest y value is 2. So our limits are going from -2 to 2. Our radius is 3 plus y. And our height is 4 minus y squared dy. If you got that, you set this up correctly. Yay! But now I'm asking you to actually find it. So you have to do some algebra to solve. Alright? Oh, I don't really want to do this. Shall I do it? I don't really want to do this. But that's okay. 12 minus 3y squared plus 4y minus y cubed. Time to anti-differentiate. 12, of course, is 12y. 3y squared, that just becomes y cubed, plus 4y is, I think, 2y squared. This is y to the power of 4 over 4. And we're going to evaluate this from -2 to 2. Lovely. 12 times 2 is 24. 2 cubed is 8. 2 squared is 4 times 2 is 8. 2 squared is, 2 to the power of 4 is 16, divided by 4 is 4, so minus 4 minus -2, so that's -24. -8 with negative is positive. 4 times 2 is 8, so that's plus 8. And then 16 over 4 is 4, so minus 4. What do we get? Let's see, that's 20. And then what's 16? Negative 8. Negative 8. Negative 20. I'm so confused. Negative 28. Negative 8 minus 4 is negative. Oh, it's just negative 12. Nice. 20 minus negative 12, of course, is 32. And 32 times 2 is 64. 64 pi. Nice. Okay. So, I want you to try example number 3. Just set up an integral. Don't integrate it. Just set it up, which can be used to find the volume of the solid which is formed if the region from example number 2 were now revolved around the line y equals to 3. So no more axis of rotation down here. Erase my R. Now the axis of rotation is up here at 3. So in this case, R would be this distance. Okay, I leave it for you as an exercise. Good luck, because I know you can do this, because you're an expert now. Press pause, you know the drill. Come back when you're done. Check your answer. See you then. What should the only difference be? The radius, so everything else should be the same. Radius I'll leave. Height's the same. And what do we have for the radius? The distance from here all the way there is 3. That's too much. I need to subtract from it the distance from here to here. And that would be the y value. So 3 minus y. If you got that, congratulations. You're good to go. Go and do the questions.